All right, so let's talk about Boyle's law. So, Boyle's law. So basically, we're talking about the relationship of pressure and volume without the relationship of temperature yet. All right, and we can see this is how basically we can look at gases and how they're compressed and the relationship of one to the other. So you can see here we've got a volume of 4 liters at 1 atmosphere. Well, when we reduce the volume of the chamber, we now increase the pressure to 2 atmospheres. And you'll notice that we decreased the volume by half. And what happened to the pressure? Well, it doubled. Okay. So Boyle's law states that the pressure of a gas is inversely related to its volume when the temperature and N are constant. Okay, so all things being constant, 70 degrees, 70 degrees, 70 degrees. So if the pressure increases, then the volume decreases. If the volume increases, then the pressure decreases. And if we think about that, that makes sense because if we were to increase the volume, we're giving the molecules more room to flow, okay? So there's more time before it hits the walls of the container. Therefore, the pressure is going to drop. Boyle's law is an indirect relationship between pressure and volume. An indirect relationship between variables means one variable increases as the second decreases, okay? And they call it an indirect relationship. Really, it is a direct relationship. It's just things are changing in an inverse manner. So one thing goes up, the other thing goes down. The other thing goes down, the other side goes up, So this is where we get P1, V1. So pressure 1, volume 1 equals P2, V2. Pressure 2, volume 2. Temperatures and moles are constant. Remember, nothing's changing there, okay? So this is where algebra comes into play, guys. This is where we need algebra. It is all about how do we manipulate this. We got to manipulate this, okay? So in order to solve for any one variable, you need to know 3 other variables in order to do so. All right, so in this case, it's saying to obtain V2, divide both sides by P2. All right, well, so basically what's happening is they're going, all right, well, I'm going to divide this side right here by P2, and then those two will cancel. But if you do it to one side, you must do it to the other. And then we'll divide P1, V1 divided by P2 here, giving us our final formula over here. So if we're looking for volume 2, it is pressure 1 times volume 1 over pressure 2, and that'll give us volume 2, the resultant volume based on the change in pressure. So, guide in using gas laws. Organize the data in a table of initial and final conditions. Where do we start? Where do we finish? Okay, organization is highly important to any of these calculations. Rearrange the gas laws equations to solve for the known equation. And what I always like to do on any set of equations, so if we look at P1, V1 equals P2, V2, since we have 4 variables, that means we can have 4 different versions of the same equation. So if we have 4 different versions of the same, I shouldn't say the same equation, 4 versions of the root equation, I always like to, in my notes, set up each one of those equations so I can just do a quick reference. Remember, it's just basic algebra as far as rearranging equations. If you do it to one side, you do it to the other. If they're tied by multiplication, to get it to the other side, you got to divide. If they're tied by division, then you would have to multiply one side, the other. All right? And then basically it's what I always call plug and chug. Once I have my equation set up, I just plug in the numbers where they need to go and put them into either my head or a piece of paper or a calculator and come up with the resultants. So Freon 12, okay, is a gas used in a refrigeration system. It consists of 1 carbon atom, 2 chlorine atoms, and 2 fluorine atoms. So what is the new volume of an 8-liter sample of Freon gas? Initially at 550 I'm going to say torr because I'm just sick of millimeters per mercury, okay, after its pressure is changed to 2,200 torr at a constant temperature, constant T. So what are our conditions? We've got our initial volume and we've got our initial pressure. We've got our secondary pressure, and we're just trying to find out what is the new volume. All right. First thing is, man, we got to have that base equation. And it was set up before, but right here, we're looking for volume 2. All right. We have divided out pressure 2 to get it to the other side here. Okay. And with that division, we end up with P1V1 over P2. All right, so now we sub in values. 550 times 8 over 2,200. Boom. You'll notice that since I have meters of mercury on top and the bottom, they're going to cancel on out. So what does that equal? That leaves us with exactly 2 liters. So when we increase that pressure, okay, when we increase that pressure, it decreased the volume and leaving us with 2 liters. All right. So for a cylinder containing helium gas, indicate if the cylinder air B represents the new volume following changes. Okay, so if pressure decreases, which one would represent? This is our initial right here. This right there. So if pressure decreases, well, what's going to happen? If pressure decreases, the volume goes up. Ding, 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 ding. All right, now, if pressure increases, if we're pushing tighter and tighter and tighter and tighter, you'll see that volume goes down. Now let's check, see if this logic is right. All right, pressure decreases, we go back. Oh, look at that. It is B. And if pressure increases, it is A. Very logical, it's this inverse relationship, so no worries. All right, so a balloon of helium gas shown as a volume, helium gas has a volume of 6.4 liters and a pressure of 70 or 0.7 atm. Okay, at 1.4 atm, what's going to happen? Okay, so this is the initial volume. All right, well, we know based on Boyle's law something's going to happen, right? So we can just knock that out. Now we know that pressure is increased. So if we know that pressure is increased and it's doubled, okay, it's doubled. It's the same amount of helium gas in there, but the pressure is doubled. Well, the volume's not going to get bigger, is it? That wouldn't make any sense, right? Because that would mean that the pressure is decreasing. So I'm just going to cross that out, leaving us only with the only logical conclusion that the balloon is going to get smaller. All right, so let's see what happens. All right, holy smokes, this whole inverse relationship is working for us. All right, so a balloon of helium gas at a volume of 6.4 liters at pressure 0.7 at 1.4. Okay, the higher pressure means the volume becomes smaller. Look at that, everybody gets a cookie. All right, we're good to go there. All right, so if we think about it in regards to our health, okay. So during inhalation, which I do a lot because I'm a smoker, the lungs expand. The pressure in the lungs decreases. The air flows towards low pressure in the lungs. All right, so we got air in going down. Lisa would kill me for this because I have no idea, but I know a little about anatomy. But anyway, lungs expand. Air flows towards lower pressure in the lungs. During exhalation, we're pushing air out. And lung volume decreases because it's getting out. So the volume's being pushed and pushed, so air will actually flow out. All right, so that's it for 11.3. Let's keep on moving on.